Today we're going to have an introduction to logarithms. So first of all, we need to ask ourselves a few questions. What's the logarithm? Why do we need it? What is it used for? First of all, it's an operation. And when I say an operation, we have several operations in math like divisions and operation, cube root, multiplication, sine or tangent. All of these things tell you what to do to the numbers. Okay, these are operations. It's the inverse function for exponential functions. So it's how we undo the exponent. Just like we know addition and subtraction undo each other. Well, the exponential and the logarithm undo each other. It allows you to solve exponential equations. And that's the main thing we're going to be looking at is being able to solve exponentials. It's often used to model the magnitude of earthquakes, among other things like decibels or acidity. It's used in a lot of finance or amortization charts for mortgages and things like that. We'll get into a couple of uses soon. First of all, let's look at a couple simple equations, and this is going to help you understand the necessity of the logarithm. First of all, if I ask you to solve 2 to the x equals 16, most students in the past would tell me to either divide both sides by 2, and I'd say that's not going to work. Or they'll say, well, Miss Adams, can't we just take the x root of both sides? And I'll say, that's not going to work. So you're going to have to use the logarithm. Okay, so I think you can look at this equation and see that 2 to the 4th power is 16. Okay, so we see that x equals 4. So we can use a little mental math to solve that. But when it comes to an equation like this, 2 to no exact power gives you 15. We're going to need a calculator to do this and the logarithm. So we're going to need the log and a calc. And you'll be able to do that soon. So the first thing I want to show you is how to convert back and forth from exponential form to logarithmic form. I'd like for you to pause the video and write these examples down. Okay, now let's look at how to convert. If we want to, oh my goodness, look what I did. This side should say logarithmic form. Alrighty, that should say logarithmic form. Okay, so let's go ahead and convert. The way you do this is you say the exponent equals log with the same base, and the 4 is a subscript. If you notice here, that's the base, that's the exponent. Okay, and the 64 is just what it equals. And that last number, what it equals, that goes right here. Alrighty, let's try it again and see if that goes a little smoother. The exponent equals, see, that's our exponent, log of the same base of 81. I want you to start seeing the connection the log equals the exponent. Okay? And so notice how the exponent has a base under it. The log has a base. Okay? Now let's see if we can go the other way. Alrighty. So we start with the base. Remember, the log equals the exponent. So that's our exponent. The only number left is 25. So what we can see is log base 5 of 25. Did you hear how I said that? That's very important. Let's write that down. This is pronounced log base 5 of 25. I want to make sure you know how to say that. Log base 5 of 25. Okay, let's go ahead and do the next one. The log equals the exponent. So I want to make sure you see that the base is 3, the exponent is 2, equals x. So look here, x equals 3 squared, which is 9. So log base 3 of 9 is 2. You're going to start seeing what's going on in a moment. But let's see if you know where all the pieces go. I like to start with the exponent equals log of the same base. So, heart, diamond, happy face. I like to say, if you're in love, you give a diamond, and that makes you smile. Okay, so here's the big picture that I want you to see. The log equals the exponent. Or you could even say the log is asking you a question. And the question is, oh, let me do like the little bubbles, the little thinking bubbles. What's the exponent? That's what the log is asking. I wrote the wrong thing. It's asking, what's the exponent? Can you hear the log talking to you? So listen closely. This is an expression, just like if I say, what's 2 plus 2? Well, 4. You know, it's as easy as that. We should be able to evaluate this without a calculator. As a matter of fact, that'd be better instructions. Evaluate without a calculator. Just like we don't need a calculator for that. Or if I ask you 6 times 7, hopefully you wouldn't need a calculator for that, and you would just say 42. So, what's the exponent? In other words, 3 to what power equals 9? This is the base. 3 to what power equals 9? 2. So log base 3 of 9 equals 2. Another way you could think of that is to say it equals some unknown number, and you can convert to exponential form. Base exponent equals. And you see that it's saying 3 to what power equals 9. And that's how we get 2. So now, what is log base 7 of 7? This is saying 7 to what power equals 7? 7 to the first power. So log base 7 of 7 is 1. 5 to what power equals 32? No power exactly. We need a calculator. What about 6 to what power equals 1? See, this is a new way of thinking. 6 to what power equals 1? Must be the 0 power. That's the only way to get that. So my answer is 1. This one's going to be tricky. 5 to what power equals 1 over 25? What exponent would that have to be? Well, here's a way you could think of it. This is really 1 over 5 squared, or that's really 5 to the negative 2. So 5 to the negative 2 equals 1 over 25. So negative 2. Don't you see how interesting logs can be? So 25 to what power gives me 5? What I really want to do is take the square root. What power is the square root? It's the 1/2 power. Okay, we're going to come back to part C. I'm going to show you how to do that on a calculator. But before I do, let's do a few more problems. It appears that we have no base. Just like when you have radicals and there's no index written, there's an assumed number there. So when it's missing, or I'll say the invisible base, is 10. Our number system is base 10. So that's the understood power. So that's base 10. So we're saying 10 to what power equals 100? 10 squared is 100. A shortcut, since it's base 10, you can just count the zeros. So if I ask you for log of 1 million, that's just 6. You can just count the zeros. Okay, what about this one? We're looking at 4 to some power equals 0. What can we put in for x? What if we did 4 to the 0? Nope, that's 1. That won't work. We say this one is undefined. There's nothing you can put there. Nothing you can put there. What about 3 to what power equals 17? What about 3 squared? Nope, that's 9. That won't work. What about 3 cubed? Oh, that's 27. That's too much. There's no value here. But if we used a calculator, we could get a decimal approximation. It's something between 2 and 3. So for this one, we also need a calculator. Let's talk now about calculators. Most calculators only have a log button, which is log base 10, and a LN button, which is what we call the natural log. And we'll learn about that next time. This is log base E. And E is another transcendental number. It has a numerical value. I'll be sharing that with you. It's about 2.71. So there's some more numbers. Can't remember off the top of my head right now. Let's look. As a matter of fact, I think that would round up to a 2. So because our calculators only have base 10 and base E, which is the natural log, we have to be able to change the base to whatever we want it to be. Okay, and I'm going to show you exactly what I mean. If you have log base B of A, you can rewrite that so that both of these can be whatever base you want. And we usually change it to base 10. Or you could change them both to the natural log. Or, crazy enough, you could change it to any log you want. And when you get into math, 6 is a popular, when you get higher into math, I should say, 6 is a popular base used in some different things. It's a hex base 6. But the most important thing to realize is that the big number goes on top and the small base number goes on the bottom. And I always say the base is B for bottom. Okay, let me show you how to use this. Example 3. Let's evaluate each log. And we're going to round to the nearest 1,000. I'd like for you to grab your calculators. Okay, whether it be a regular calculator or a cell phone calculator, doesn't matter. Okay, I just grab my cell phone so I can punch log 40 and notice this is base 10, so we have a button here. 602. Thousandth, that's 3 decimal places. And remember, you check the next number to see if it's 5 or higher, and then you go up. Now for this one, my calculator doesn't have base 4, so I'm going to punch log of 126 over log 4. And now on my calculator, either use the fraction key or when you punch it in, use parentheses just to make sure the order of operations doesn't get crazy. Okay, most calculators are pretty smart though. So I'm going to clear the last problem out, and we have log of 126 divided by log of 4. And by the way, I mentioned order of operations. Where do logarithms come in? That's going to round up to a 9. Excuse me. That's going to round to a 9. Where do logs come in the order of operations? Please excuse my dear Aunt Sally. Exponents are here, so we do exponents and logs in order from left to right. So that's an important thing that is going to come up over and over again. So make sure that you're very clear about where that falls in the order of operations. Okay, now we're going to do part C. This is log of negative 20 I'm using my base change formula. So either use a fraction key or use your parentheses. So log 2, oh no, that's log negative 20. And oh my goodness, do you see what's going on in your life? The calculator says no thank you. It either gives you an error or syntax, or it just doesn't want to do it. And I'd like to explain something to you. If you have a log, let's say y equals log base b of x, we're going to soon see that the graph goes like this. Never, ever touching right here, never becoming negative, and never touching 0. Okay, so what we're going to learn is that this number right here must be positive. And it's a domain issue. And you're going to learn that as well. And when I say positive, that means 0 is not allowed. Negatives are not allowed. And when I say not allowed, they're undefined. Okay? They just don't happen. Alrighty. And we're going to learn a little more about B also.